Now let's talk about some of the types of the model which we need to know for the exam. So the first one is the foundation model. So it's a massive AI model trained on vast amount of data. Vast amount means millions and billions of data we provided it with learned. Okay. And this is like the core of the Gen AI. The Gen AI which we use today. Foundation model is the back of it. Okay. Some of the examples you can think of like the GPT, okay, then the Meta Llama, and then Google's Gemini or Anthropic Claude. Okay, these are some of the foundation models which we use every day. Right now, this why this is called foundation model. This is a model for everything. Okay, like it is trained with everything, every general data which we need for it to answer any general question regarding to related to the whole world. Okay, we can ask it questions on stock analysis. We can ask it questions on any general concept. We can ask it for anything, right? We use it every day. So it's a model which can be used as a foundation or as a base for creating your specialized models. Okay, let's say we have our specific requirement. Let's say to just let's say we are going to create a stock analysis, Indian stock market analysis. Okay, and now to create this, so we are going to have a lot of data which are specific to Indian stock market or which are specific to our application. Okay, our application has to be different from whatever applicable. Okay, so for that we are going to provide it with some specific data. Okay, but that data would not be enough, right? It has to know a lot of general data as well. It has to know about a lot of things in the world. Okay, let's say we have said like this stock is uh, doing something like providing some stock split. Okay, so now that stock split we have provided it, but what that stock split will have the impact on in the real world. So for that we don't have to provide it because the foundation model, which is the back of it, is already having that information that when a stock splits, what happens. Okay, so that foundation model is already knowing everything, and on top of it, you are providing it with your own data to create a specialized model. Okay, and the foundation model is multi-model. Multi-model means it supports multiple formats. Okay, like text, image, video, or any other kind of files. Okay, so remember the concept of multi-model. Multi-model means supports multiple formats. Now, the large language model. This term also we would have heard a lot. So, large language model is simply a foundation model which is limited to text. Okay. So, if your foundation model uh, can just take text as an input and output text only, then it's a large language model. Next, let's talk about diffusion model. So diffusion model is a type of foundation model which is specialized for image generation and image quality enhancement. It can be used for other things also, but this is a specialty of it. Okay. Here we have the concept of diffusion. Okay. Diffusion is basically converting a image, adding noise to a image. Okay, and step by step keep on adding noise to your image. That's called diffusion. Okay, and removing noise is then reverse diffusion. So this Diffusion model, basically what it does is you provide it with real images, okay, and then it will keep on adding noise to it until it becomes completely noisy. It becomes unidentifiable, okay, and then using those noise, it can regenerate completely new images, okay. So how it generates from the actual image to noise, it tries to reverse the step to generate a completely new image. It will not generate the already provided image to it, but a new version of it, completely new image it can generate. Okay. So this is a very important concept in Gen AI. Nowadays, we see like we provide some text input, like generate an image for this, and the image is going to provide you. It's not anywhere in the world. It's generates on its own. Okay. So diffusion model is being used there. So for the diffusion model, remember the concept of forward diffusion and reverse diffusion. Now let's talk about GAN model, which is generative adversarial network. So this the use case you can think of like generating realistic images, which sometimes we call as deepfakes. Okay, some images or even videos which you cannot identify if it's a real or fake. Okay, and then it can also help in image resolution enhancements. So the concept of GAN is there are two neural networks which are competing against each other. The first one is the generator. Generator will try to create fake image, okay, which looks like real. And then there would be a discriminator. So whenever generator generates an image, the discriminator will take it and compare it with the real images it has in its data set. It will compare it and then will try to distinguish like if it's a real or fake. The image generated by the generator, it will tries to discriminate that image with a real image. Okay, and this keeps on continuing. Generator generates the image, discriminator tells no, it looks fake. Generator again improvise, and then again discriminator tries to do, and this continues until generator generates an image with the discriminator is not able to tell if it's a real or fake. Okay, so whenever you have this term generator and discriminator, it is the GAN model. Okay, and then it's like two neural networks, generator and discriminator, two neural networks. They are competing against each other to get the best output for you. Now let's talk about VAE model. So this is variational auto encoder, and this is used for data compression, okay, and anomaly detection, and some other use cases are there. So VAE model, what it tries to do is it tries to find the blueprint of your data, okay, by squeezing it down, and then once it squeezes it, it tries to blow it back, like revert it. Okay. So here again we have two neural networks, but they don't compete with each other. They work in parallel. Okay. The first one is the encoder. The work of the encoder is the data it gets. It tries to convert it into a tiny simplified version. Okay. And it keeps it in its latent space. And then there is the decoder, which takes the tiny representation of your data and tries to reconstruct the full data from it. Okay. So it's a little simple, similar to the GN model where we have no, not GN, but the diffusion model. It is similar to diffusion model where we, from the real image, we try to add noise to get a noisy image and then reconstruct to get a newer version of real image, real looking image. Okay. So similar concept is here also. It tries to, whatever data you give to it, it will try to change it to a simpler representation, and then from simpler representation it will again simpler or and tiny representation of it. Okay, and then again from that it is trying to reconstruct it into a full data, a real like data. Okay, so if you try to understand how exactly it works, it's a very vast concept. If you are interested in it, you can do it. But from the exam perspective, all you have to remember is here we have two neural networks which work in parallel, and they are the encoder and decoder. So whenever we talk about encoder and decoder, it's the VAE model. Okay. There would be some questions attached in the YouTube description related to the topic. Please try them out.